Hey everybody, welcome to topic number 4. Let's review operations of polynomial. So what is a polynomial? A polynomial is actually made out of many unlike terms with the same variable, but the exponents are different. Okay, so this right here I wrote is a generic form, a standard form of a polynomial function. All right, polynomial using the variable x is equal to x of n, x to the n power plus x of n minus 1 to the x um, x to the n minus 1 power, so on and so forth. So from here, what we see here is all the terms, right? Lots of plus signs, all the terms using the variable x, okay? And these, what's in front of these x, okay, is all coefficients. The n minus 1, n minus 2, those are your exponents, okay? So normally, a polynomial is actually written in the descending order on the exponents. So if I would say this exponent is a 5 first, then the next one is n minus 1, which is 5 minus 1, 4. Then the next one is 3, the next one is 2, then this one is first power, and the last one is always x to the 0 power. Every term using the variable x, the very last one is actually x to the 0 power. So one of the exponent rule says x to the 0 power is only 1. That's the reason why here you do not see any variable on the very last term. So if you have a polynomial function where one term does not have any x on it, that is called a constant term. Generally, the constant term should be the last term of a polynomial It's called a constant term. Okay. So the reason why we know for a constant term we do not write a variable is because x to the 0 power. So for example here, 2x to the third power plus x squared minus x plus 4. So this is an example of a polynomial where every term using the variable x and your exponent is written in descending order. Okay. So these s of n and s of n minus 1 are just coefficients. Okay. What's above all the variable x are your exponents. So in your own word, on the first discussion question, why is a constant term in a polynomial does not have a variable? Well, it does, right? A constant term does not show a variable because it is x raised into the 0 power, okay, which is equal to 1. That's why we normally don't see that x to the 0 power. All right, so here, polynomial is always expressed as in descending or ascending order on the exponent. What is so-called the degree of a polynomial is referring to the highest exponent of a non-zero term in a polynomial. So here, if you actually look, this example, the highest exponent that we see here is 7 power. So the degree of the polynomial is 7. The degree of polynomial tells us, okay, what is other than the highest, what's the highest exponent. It also tells us what type of polynomial it is, okay? We will talk more about the different types of polynomial later on. But you also tell me who should be the first term. If the degree is 7, that means 4x to the 7 power should be your first term. So the next term got to go by, so if we go by the exponent, the next term got to be 6x to the 5th, and then 2x to the 3rd, and then your x squared term. So this example, I don't have a constant term, okay? So this is actually the way how we will write a polynomial, write the exponent as in descending order. Okay, so what's supposed to come after 7 power is actually 6 power. The reason why I don't see it because it's considered as a missing term. Okay, a missing term is actually a term that is actually a term that has coefficient 0. So my missing term here is 0x to the 6 power. Okay, I don't see it because it's missing. It's missing because the coefficient is actually 0. So 7 power, 6, 5, and then there should be, I'm missing a 4th power, okay, 3, 2. Of course, back here, I'm missing a x to the, missing a 0x to the first and a constant term. I'm missing those as well. We're not going to use too much of, on the missing term until later on the semester. In other topic, we will need these missing terms, especially when it comes to dividing polynomials. We will definitely need need these missing term as a placeholder. Okay. So what is a polynomial exactly? Excuse me. What is a missing term exactly? A missing term in a polynomial normally has a what? Has coefficient 0. Okay. All right. Different types of polynomials. A monomial or a monominal is a polynomial with one term. Not just any one term. It needs to be a term with a variable has some sort of exponents on it. Like 3x to the fifth power, right? Because behind x to the fifth power here, I should have 4, 3, 2, 1, 0 power. They're all missing, right? They're all considered missing term. So a monomial is really a polynomial with one term, and that one term need to have some sort of exponents on them. Okay, you cannot consider a constant term, right? X to 0 power, a constant term as a polynomial. That's not what the word is used for. These words are used for specific circumstances, basically. A binomial is polynomial with two terms, not just any two term. We use this word binomial to describing the type of problems dealing with polynomial, just like a plus b times a minus b. So this is actually considered as a binomial times binomial, or two term times two terms. A trinomial is not simply just in a polynomial with any three terms. To be specific, a true trinomial, what is considered as a true trinomial, is actually the last three terms of a polynomial with exponents that are factors of 2 power, 1 power, and 0 power. So let me go back up here real quick. What's considered as a true trinomial is the last three terms of a polynomial. So if you actually count back, constant term, first power, second power, these three terms will be considered as a true trinomial. Okay, where your exponents are generally, in the factors of 2 power, 1 power, and 0 power, the 2, 1, 0 power. Okay, that's what a true trinomial is. So the word is used for very specific types. The word trinomial is used for very specific types of a polynomial problem. Okay. All right, polynomial just like this example I have would just be a polynomial, just with many terms, polynomial with many terms. So what we can do with polynomials is we can add them, subtract them, and multiply them. We'll talk about dividing polynomial in a different topic. So let's do add and subtract polynomial. So add and subtract polynomial is just like combine like terms, what we talked about in the previous topic. So when we actually combine like terms, we will only add or subtract the coefficient and do nothing with the exponent. So I'm gonna perform the operation of polynomial just like what I learned before, just what we talked about before. The purpose of parenthesis here is to indicate I got one polynomial, it's trying to add on to another polynomial. So with this plus sign outside the parenthesis, I know in front of it, this is one term. Behind it, oh, this is one term. The plus sign go with the term that follow right behind it. So my second term is technically a positive one that will do a distribution. So I'm gonna add these two polynomial using distributive property, then combine like terms. So in front of this first yellow term, there's nothing there, so that got to be a positive one there that will do a distribution. So let's bring these terms to the outside the parenthesis before we combine them. So positive one time these three terms, all three terms will come out to be exactly the same. Positive one time these second term, these three terms for the second term in blue. Positive one time 3x squared, positive 3x squared, positive one times positive ax, positive ax, positive one time negative 9 is negative 9. So now I got 6 terms outside the parenthesis. The degree, the highest exponent is 2, right? So that tells me the second power got to be the first term I combine, okay? So combine like terms, 7x squared plus 3x squared. That should give me 10x squared. Okay, combine like terms. 5x plus 8x. That should be positive 13x. Combine like term, negative 8 minus 9. Term with the same sign we will add. So that will give me 17. Because both terms are negative, my answer is negative 17. So once I add these two polynomials together, I get 10x squared plus 13x minus 17. Okay, let's try another one. All right, this one is subtracting of two polynomials. So again, I'm gonna use distributive property to do this example. So this time, with the subtraction sign outside the parenthesis, in front of it, this is one term. Behind the subtraction sign, oh, this is one term. And the subtraction sign go with a term follow right behind it. So my second term here is really a -1 that will do a distribution, right? My first term, there's nothing in front of the parenthesis, so that's a +1 doing distribution. Okay, so +1. So for the first term, +1 multiply these three terms inside, it will bring them out to be exactly the same. Okay, second term in blue, -1 do a distribution. -1 times 3x squared, -3x squared. -1 times positive ax, -ax. And -1 times -9 should be +9. So once again, the degree is 3. So combine like terms, excuse me, degree is 2. Combine like terms, the square go first. 7x squared minus 3x squared, 4x squared. All right, combine like term. First power, 5x minus 8x. Term with different sign, I subtract. That should be -3x. Okay, combine like term. -8 plus 9, or if I swap it, it'll be 9 minus 8. Term with different sign, I subtract. That will be +1. There you go. All right. All right, let's take a look at how we can multiply polynomials. So when we multiply polynomials, right, we're gonna multiply the coefficient and add the exponent, just like from the previous topic, right? X times x, right? When the variables are multiplying, we are adding the exponents. So here we're gonna multiply the coefficient and add the exponent. So for this example, we're gonna multiply polynomial and not combine like term or rearrange. I'm just gonna multiply them out. So this is 2 term times 3 terms, okay? So the way how we're gonna multiply polynomial is just like distributive property. Pretend the -2 is not there. So the 3x will multiply, will do a distribution onto what's in the second parenthesis. And then once I'm done with that, I pretend that the 3x is not there, and then use a -2 to do a distribution, okay? Because both of these terms up front will multiply those 3 inside the second parenthesis. So basically that's how we're gonna do this, okay? So I'm gonna try to color code this. So 3x times 2x squared. 3x times 2x squared. 3 times 2 is 6, right? X times x to the third should be, excuse me, x times x squared should be x to the third. When we multiply the variable, we got to add the exponents. So 3x times 2x squared, 6x to the third. 3x times -ax, -24x squared. Okay, x times x, x squared. Got to add the exponent. 3x times +3, +9x. So that's it for 3x doing distribution. Now, -2's term. -2 times 2x squared, -4x squared. -2 times -8x, +16x. -2 times +3, -6. All right, the highest exponent here is 3. My degree is 3. So 6x to the third go first. Nobody to combine with, so still 6x to the third. All right, square go next. Combine like terms. Negative 24x squared minus 4 more x squared. Term with the same sign we will add, so that'll be negative 28x squared. Combine like terms, 9x plus 16x, positive 25x. And at last, just negative 6. There you go. So when it comes to multiplying polynomial, it's just like a distributive property. It's just like distribution. All right, let's take a look at this thing called spatial product. Spatial product are meant to be done simply just by looking at it. Okay, the first one I want to review here is called the FOIL method. Okay, FOIL method is only used when we have two term times two terms. Okay, the FOIL stand for first, outer, inner, and last. So I'm gonna write this example here. Okay, here on the side. So this is just like what we did with the polynomial, with the multiplication of polynomial, except this time is two term times two terms. So basically, this 2x will multiply the two term in the second parenthesis. 2x will times 3x minus 4. So I'm gonna write it out. If I write it out, it will look like this: 2x times 3x times 3x minus 4. It's a distributive property. And then positive 3 will do the same thing. Positive 3 will do a distribution itself onto the same two term in the second parenthesis. So basically, it's like this when you write it out. But FOIL method is designed just by looking at it. Okay, so the first thing you do is 2x times 3x. That's what it's called F. 2x times 3x, right? 2x will do a distribution. So the first thing is 2x times 3x. X times x is x squared. So 2 times 3 is 6, right? X squared. Alter, the two outside term multiply together, or the two outside number multiply together. So the O is altered. 2x times negative 4, which is negative 8x. All right. The inner, positive 3 times 3x, that's the inner, positive 9x. And the last thing I do is this positive 3 times negative 4, that's the last, which is negative 12. All right, combined like term, degree is 2, so 6x squared, still 6x squared. Negative ax plus 19x, positive 1x, and still got negative 12. Okay, so remember, this problem is designed to do it just by simply looking at it. So what we normally do is this, okay? This 1x, this final answer, 6x squared plus x minus 12, is actually a true trinomial answer. This middle term, the answer of the middle term here, the middle term of the answer, right? The 1x actually come from the inner and the outer combined. All right, the 1x come from the negative ax and positive 9x. Negative ax was the 2x times negative 4, that's what the outer. The 9x was the inner. So in the trinomial answer, the middle term of this trinomial answer come from inner and outer combined. So if we know that, then we can actually do FOIL method simply by looking at this. Because the first thing I do is 2x times 3x, which is 6x squared. The last thing I do is 3 times negative 4, which is negative 12. So this middle term come from the inner and outer combined, right? So the outer is negative ax. The inner is positive 9x. So 9x and negative ax combined should be positive 1x. Okay, because the next topic when we review on how to factor trinomial, we're gonna do the FOIL method backwards. That's the reason why I want to mention that FOIL method is really meant to be done by simply looking at it. Okay, so we're gonna do this backwards in the topic number 5 when it comes to factoring trinomial. But normally FOIL method, right? First, outer, inner, and last, and then combine like terms. The next special product is called the difference of squares. To recognize difference of square, you got to see that this is a 2 term times 2 terms, right? The first term in both parentheses are the same, a and a. The second term in each parenthesis in both parentheses are the same. One parenthesis has a plus sign, one parenthesis has a minus sign. Okay, that's how we know it's a difference of squares. The name of this special product is what the answer should look like. Difference means subtraction of 2 perfectly square terms. Okay, so what happened to the middle term? If you think about FOIL method here, what happened to the middle term? The middle term actually got canceled out because a times negative b, the outer a times negative b is negative ab. Inner positive b times a, positive ba or positive ab, either way you say it, it's the same thing. Ab and ba are the same. So negative ab plus positive ab actually kind of canceled out. So difference of square doesn't have a middle term because it got canceled out. So you're just going to be a squared minus b squared. So to do difference of square is meant to be done by looking at it. Okay, your first term in both parentheses are 2a. So this is like my a and a. Both second term in the both parentheses is 3. One parenthesis has plus sign, one parenthesis has a minus sign. So this is a typical difference of square problem. So difference of square says take your a, 2a, whole thing squared. What is 2a whole thing squared? So you see that's like a power rule, right? 2 squared is 4. A squared is a squared. Remember, power rule, the exponent on the outside will distribute the power onto all the factors inside. Minus, my b is 3. 3 whole thing squared would just be a 9. There you go. So the answer is 4a squared minus 9. That's all it is. So we'll do a lot of difference of square in this class. The next special product is called the perfect square binomial. Perfect square binomial here, a plus b whole thing square. I think I mentioned something like this in the previous topic. Okay, a plus b whole thing square. I cannot say this is a squared plus b squared. That's not what that is. Cannot apply the power rule when there are 2 terms inside. But we can look at it. We can look at this problem as a plus b times a plus b. So we know it's a perfect square binomial because what's inside the 2 parentheses are exactly the same. That's why we say a plus b whole thing squared. So think about the FOIL method. First thing you do is a times a, which is a squared. Last thing you do is b times b, which is b squared. The middle term here come from the inner and outer combined. Your outer a times b is ab. The inner b times a is ab again. So how many ab do you have? 2 of them, right? You got 2 of them. That's why it's called a squared plus 2ab, 2 of the same inner and outer, plus b squared. And this is a minus version of it. Okay, so I'm gonna write down this formula and we will just follow. Okay, we'll give this a try. A minus b whole thing squared. So my a is 5x, my b is 3. So we will follow the formula. My a gotta be squared. So that's my 5x. Whole thing gotta be squared. So 5 will be squared, x will be squared. So that's 25x squared, right? 5 squared, x squared, 25x squared. Minus 2 times my a times my b. Take a number 2, right? Because I got 2 of the same middle term. I got 2 of the same inner and outer. 2 times my a, 2 times 5x is 10x, times my b. So that's 10x times 3. That will be minus what? 30x, right? The sign says minus. Plus my b got to be squared. My b is 3. 3 squared is 9. So that's your answer. 25x squared minus 30x plus 9. Okay. All right. So we will do this a lot as we go along this semester. Okay. So in your own word, okay, which special product? If you look at this problem, which special product is it? It is actually best describe this multiplication. For your method difference square, perfect square binomial, and the reason why. So once you decide which type of special product this example is, then you need to tell me the reason why. Okay. All right, so we quickly reviewed on the operations of polynomials, talking about the degree of polynomial, talk about how we can add, subtract, and multiply the polynomial, and we quickly introduce the special product. Thank you so much for watching.